Hello and welcome to Chemistry Time with Mr. Barkland. Hello! Wow, I just hit my head there on the hydrochloric acid. Be careful. That brings me to my first point, safety. One of the most important things about this lab is keeping track of your chemicals. Notice we've got dihydrogen monoxide, we've got hydrochloric acid, which is very corrosive to your skin. We've also got hydrogen peroxide. We've got zinc, it's called mossy zinc, it just means it's these chunks of zinc, and then we've got manganese dioxide over there. That is our catalyst for generating oxygen with hydrogen peroxide. So, after pointing out the cast of characters here, one of the other things you need to be really careful about in terms of keeping track of these is if you add hydrochloric acid to manganese dioxide, it actually generates chlorine gas, which is poisonous, so we want to avoid that. We want to keep track of what chemicals we have where. The very first reaction I want to get going, just because it sometimes takes a little bit of time to ramp up, is adding hydrochloric acid to some zinc, or the other way around. It doesn't really matter too much. So I'm going to go ahead and open up my zinc. Notice I've got maybe about 4 or 5 pieces. I'm going to put one of these back. This is probably plenty of zinc for us. But I'm going to go ahead and put that in our first test tube. There we are. And I'm going to add some hydrochloric acid to that. I'm going to add 20 milliliters of hydrochloric acid. The exact amount does not matter too much for this lab. That's just kind of a good amount to keep this reaction going. It's about 18-19, that's good enough. So we will pour that into our test tube. And if you take a close look, you should be able to see those bubbles already forming. Those bubbles that are forming are hydrogen gas, so this is our hydrogen generation. Notice that how many bubbles are forming right now. Compare that to how many bubbles you see forming later. You might notice a difference. So we'll put that back. I'm going to put our stopper on there. Notice that our stopper has this plastic thing sticking out of it. This is actually, remember that lab, the CSI lab where you were using all these droppers? I'm using some of our dead and broken droppers, cutting off the stems of these and putting them inside of the stopper to basically be a gas delivery device. Stick that on there. Next thing to point out is how you make your rocket itself. So I ordered some more droppers. Notice these are wide stem droppers. What you're going to do is you're going to cut the end of the pipette stem about ½ centimeter from the end of the bulb. I'll let you measure that with a ruler. Should look like this. After that, you're going to take a marker and you're going to make some markings on the side of your pipette bulb. I'm going to put 5 markings on there. Let's see how well I can mark. Not very well. You can probably do a better job than I can on this. And I'm actually even let's add a 6th there down at the bottom. But we've got 1, 2, 3, 4, 5, 6 different sections where we can kind of measure how much gas we have. Ideally, these should be about 6 equal sections. So try and be as precise as you can with that. Better than what I was right there. Okay, next step, I'm going to fill this up with some water, otherwise known as dihydrogen monoxide. So add some. Notice I push out that air. Add a little more. Still got a little bit of air in there. Push the last little bits out. And now we should have a beaker filled with 6 parts water. What I mean by 6 parts is all 6 of those kind of chambers or compartments in there are filled with water. Now it's time to start generating our oxygen gas. The reason I'm waiting on this is the oxygen gas reaction happens pretty fast. It uses up the hydrogen peroxide pretty quickly. So we've got manganese dioxide. I'm going to add just a little bit. Notice that I've got kind of, a dime-sized scoop or so of manganese dioxide. Once again, the actual amounts don't matter too much for this. Depends on the lab if the amounts matter or not. So we add that to the bottom of our test tube. And you're going to actually use that same manganese dioxide for all the days of your lab. I'm going to actually have you hang on to your test tube and reuse that manganese dioxide because it's catalyst. It means it helps with make the reaction happen, but it doesn't get used up itself. So, oops, okay. We're going to add a little bit of hydrogen peroxide now. Let's move this out of the way. I'm going to only add about 5 milliliters of this at a time. You really don't need very much, and because it gets used up so fast, you're just wasting it if you use more than, about 5. So I'm going to pour this in our manganese dioxide. That should catalyze that reaction. You can see how many bubbles are forming there. All of those bubbles are oxygen bubbles. So we will put our stopper on top of there. And now we're ready to fill our rocket. Okay, so watch how I put, I'm going to move the gas generation. Oh geez. Okay, sorry, struggle street here. I just want you to be able to see what's going on here. So I put it on top of here. The oxygen goes really fast. If I show you a close-up of that, we now have 1, 2, 3 parts oxygen, and we've got 1, 2, 3 parts water. So what I'm going to do is I'm going to put the pipette bulb, the rocket, now on a hydrogen gas generator. This one goes a lot slower, and you'll notice that we now have all air in here. It's half oxygen, half hydrogen. They're actually mixed. They're not staying in their two halves like that. But we've also got some water there at the bottom. It's really, really important to keep that kind of sloped part there full of water. It actually helps act as a seal to keep the gases inside of here. So I'm going to put my primed rocket, our fueled up rocket, on top of our launcher. I'll explain how this launcher works in just a bit. I've got it on there. And hopefully it's going to work. I'll go ahead and press the button and there it goes. So now what you would do is you'd measure how many meters that rocket went. Thinking about control variables, you want to be consistent in the way that you are measuring that rocket distance, so kind of how you think about that. Okay, a little bit about, let's talk about the rocket launcher here briefly. So this is a little contraption I built this last week or two here. In the Gates lab, we've got a block. I drilled a hole in here and I put a piezoelectric igniter. This is the same thing from the barbecue lighters. I actually bought some special ones that are a little bit easier to press. But if you take a look at the end of those two wires and I press the button, you should see a spark happening there. So basically, I left a little gap between these two wires, and then the spark travels, the electrons travel over that little gap in the air. That spark should ignite our hydrogen and oxygen combination. Okay, the ones that you are going to be using ideally will be a little bit better, a little bit smaller wires when you are all at FCD tomorrow, if I'm saying that right. I will be running off to Home Depot and getting some smaller wires, maybe building a little bit better launchers than this one that you see here. It's important to make sure you're using the same launcher every time because all of these are slightly different. I've glued the bottom here so that it's kind of launching at an angle and that the launcher down here is not getting bent. Going back to kind of the purpose of this lab, so I did 3 parts oxygen, 3 parts hydrogen, and I can measure how far that rocket went. Now what you would want to do is measure different amounts of hydrogen to oxygen ratios and see if that what kind of impact that has on how far our rocket can go. We're going to tie that into thinking about balancing chemical equations, why that's important, and hopefully have a little fun while we're at this. I just wanted to point out that I have been wearing my proper safety equipment while we have been doing this lab. You do want to keep your goggles on. That's about all the safety equipment that we will be using during this lab, but it is important to have this on because we do have some corrosive chemicals, we do have projectiles flying about, and that is it for our Microrocket lab. So I hope that Chemistry with Mr. Barkle has been a good time for you, and we will start this lab on Wednesday. Make sure you've read through the instructions as well and answered the questions on that lab sheet.